Hello student, the question says the resistance between the terminal points A and B of the given infinitely long circuit will be. So there is an infinitely long circuit is given. We have to find resistance between the terminals across A and B. So let us see how are we supposed to solve it. Suppose if we have an infinite circuit, okay. So the easiest way to solve this infinite circuit is if you notice it, even if I remove a section of this, suppose if I remove this entire section, it still looks the same because this keeps on continuing till infinity. Even if I remove one more section also, it still looks the same. So in infinite circuit, even if you remove one small section, it will the entire circuit will still look the same. It's like if you have an ocean, what happens when you remove a drop from an ocean? The ocean still looks the same. So the same logic goes. So in an infinite circuit, even if you remove one circuit, the remaining circuit still looks identical. So suppose if I remove this and consider these 2 points as C and D, and the R effective across this entire thing. What is the effective thing across this entire thing? If I call it R effective across C and D, I'm assuming that the effective resistance across this entire remaining circuit is R effective. Now, the same effective resistance would come across A and B also. Whatever is the effective resistance between A and B is there. The same effective resistance I can expect across C and D if I remove this left side circuit. I hope you understood this logic. So in infinite circuit, even if you remove a small section of it, the effective resistance doesn't change. So we will use that logic to solve the problem. What we will do is, I will redraw this diagram with only this section intact. So I can redraw this diagram as R, and this is R. If the effective resistance across, so let effective resistance across AB be some, since this is RAB, I will call it as R effective. So RAB is, I'm calling it as R effective. So whatever is across AB, if I remove that section, across CD also we must get the same thing. So we'll get again R effective. So this is a very interesting way to solve infinite series problems. Then here we have R, and this is AB. Now let us find what is the effective resistance now. Now this is very easy to solve because these two are in parallel. Since these two are in parallel, I can write their effective resistance is, this is R. So we know in parallel the formula is R1 R2 by R1 plus R2. So R into R effective by R1 plus R2. So R plus R effective. So this is what we will get. And here we will have R. Now the effective resistance across RAB is equals to, this is, these three are in series, R plus R into RE divided by R plus RE plus R. We assumed RAB itself as RE. So we can write this as RE equals to 2R plus RE by R plus RE. This method might look very different for non-mathematics students, but for math students, this is generally how we solve infinite series. Now let us, if I find RE, my problem is done. So let us rearrange these terms. I will take it to the next page. At the end of this video, I will teach you even more interesting way. Rather than remembering this formula, we will solve this problem with logic also. So let me take these terms to other side. So I will get RE into 1 minus R by R plus RE. Or else I will do LCM here itself. So I will get RE equals to 2R into R plus RE plus R into RE divided by R plus RE. If I take this term to the side, RE into R plus RE square equals to 2R square plus 2R into RE plus R into RE. So bring all the terms. We need to find R effective. So rest of the terms, if I bring one outside, 1 R into RE, 1 R into RE, we can cancel it. So RE square minus 2R into RE minus 2R square equals to 0. So here the variable is RE. Here where RE is variable, here R is known. So we know if AX square plus bx plus c is equals to 0, the answer for x is equals to minus b plus or minus root of b square minus 4ac by 2a. Since in our expression here, whatever is in front of x square, here a, from our expression it is 1. B value is minus 2r. Here r is a, here re is variable, r is known thing. And c value is minus 2r square. If I substitute that, we will get re is equals to minus b plus, I cannot write minus plus or minus. The reason is effective resistance has to be positive. It cannot be negative. Resistance cannot be negative. B square is 4r square minus 4ac if I substitute it, plus 4 2s are 8r square divided by 2a. So you'll get Re equals to 2r. This is 12r square. 12r square can be written as 2 root 3r. So 2 root 3 into r, because root 12r square is 2 root 3 into r divided by 2. So we basically get finally in infinite series, in infinite series with equal resistance, it is better if you remember. So the formula for R effective is, if I remove this 2, we'll get root 3 plus 1 into R. Root 3 plus 1 into R. This is the formula that we are getting. So based on this formula, what's the correct option for this? So root 3 plus 1 into R. So in our given problem, R value was 1. So based on that, we can write R effective equals to root 3 plus 1 ohm. Now, is this the only way that we can solve this problem? Is maths is the only way to solve this problem? Can't we solve this problem without using any mathematics? Let us assume you don't know any math, okay? If you don't know any math, can we still try to solve the problem? Let us see how can we try this qualitatively rather than quantitatively. Every time in physics problems, it is better to think both qualitatively and quantitatively also. So if I try to think, we know we have to use a property of parallel. In parallel, the R effective would be lesser than both individual resistance that get involved. Let us say if you have two resistors R1, we have one more resistor R2, and if I try to find R effective across them, their in parallel their R effective would be lesser than R1 and R2 individually. So if I use that logic, I will write 1 here. Here 1, because of entire other thing, if I assume R effective, because of the entire other thing, if I assume R effective, so I don't know what is this. Let us assume because of the entire other thing, I am getting something here. Okay, some resistor R I am getting because of the rest of the part. This is 1 ohm, and we have this again 1 ohm. Between 1 and R, we can clearly tell. So my R effective will be whatever is the effective resistance between these two. Okay, so if I try to solve it, it has to be lesser than 1 ohm. So I can write 1, and here between these two I can write less than 1, and then we have 1. So this is A and this is B. Now my answer would be, if I want R effective across A and B, it will be 1 plus another 1 plus something lesser than 1. Okay, it would be some positive number only. So 2 plus less than 1. So it would be 2 point something. My answer has to be 2 point something, but I definitely know it has to be greater than 2. Let us check the 4 options that is given to us. One is, if I compare all these options, we will get to know a very interesting way to solve the problem. So finally, I came to know after solving that my answer will always be greater than 2r plus something. Understood? So with that logic, we got our answer is greater than 2 plus something. Since it must be 2 plus something, this is root 3 minus 1, which is 0.732. No, it can't be my answer. 1 minus root 3 itself is negative. This is straight away eliminated. We cannot have negative resistance. This is 1 plus root 3. Okay, so 1 plus root 3 would be 1 plus 1.732. It is 2.732. Yes, we are getting 2 plus something. And 2 plus 1.732. So you are getting 3.732. But my answer has to be 2 point something. 2 plus less than 1. Remember, if we add 2 with less than 1, we'll get something decimal. So based on this logic also, we can directly mark it as option C. So remember, sometimes you have to think out of the box also. You should not always rely on mathematics. So I hope you understood. So let us say 1 and another 1 ohm is given here. We can assume that anyway my answer has to be greater than 2, because whatever comes here it will be lesser than 1. So 2 point something would be my answer. We can delete for same thing also. Let us say an infinite ladder is given for 2, 4, like 2, 4, or this is 2, and again, like let us say the same set is getting repeated, 2, 4, and another 2. In this way, we can definitely tell whatever are the options that we are getting, it will definitely be lesser than 4. So 4 plus less than 4, and we can check the options, whatever is the right option, then we can mark it. I hope you understood how I have solved in both the methods. Thank you.